In this video, we're going to discuss profiling data. Typically, when we're monitoring water quality, we have sensors deployed at fixed locations, and those fixed locations will record values over the course of time. So our data will come in time-tagged format or time series format. What we're going to do in this particular example is go through data that actually has both a time and a spatial or a depth component with it. Now typically this data might be collected by going out into the field, say once a week, dropping a sonde over the edge of a boat in a lake or in a reservoir, letting it down to specific depths, taking measurements at those depths, and then bringing it back up, taking it in, and then a week later going back and performing the same type of survey. So to bring in and then visualize some of this data, I'm going to start with an import from Filebox. I'm going to drag it out onto the whiteboard, double click on it in order to run it. And what we're going to do is we're just going to load this type of data, and we're going to bring our data in the form of two time series. One time series for the depth component and one time series for the actual values we're going to be looking at. So I'm going to click to load, and the data I have here is from Cowichan Lake. If I double click on this, we'll start by bringing this data in as time series. If I go to the next step, you can see there are a few header lines here that just tell us the equipment that we were using and the lake location that we were at. And we want to start the import, this case on row 5. All my other parameters here are right as my defaults, my comma as my delimiter, no other parameters. In the next step, we're going to tell AQUARIUS what the formats for the date and time are. These two columns are my date and time. The first one starts here as it appears as though it's day, month, year, but if we scroll down, it actually looks as though it's month, day, year. So what we're going to do is actually enter this. This comes from typically opening the file in Microsoft Excel, and Excel will apply its own regional settings. So we've got to be sure about this, and this goes mm/dd/4-digit year. And then we're going to do the same for the timestamp to go along with it. This one is HH:MM:SS. Because we have seconds in this case. Now all of our data columns are actually coming out correctly just because of the way the file is formatted. The two lines above where the data actually starts are where we're getting the description and units from. And we can see here our last column is actually our depth column. You can see how it goes down and it eventually tops out at 14.6 meters, and then we get the next profile starting about a week later. So there's a significant jump in the timestamp here. And you can see we don't have evenly sampled data as we went down. It was just when the data was told, when the sonde was told to record at that specific depth. So I'm going to click Next. I'm going to finish this. I don't need to save it as a configuration file in this particular case. We're going to finish that. It's going to bring it in. If there are any invalid time values found, it'll warn me about that. What we're going to do is just click to have a look at this data on the whiteboard. So typically the way we'd look at time series data would be to wire this up to a quick view toolbox, just to right click on either the ports or the wires to grab a quick view. We're just going to look at this type of data. And in a second it'll show up. There we go. So we've got our profiling data here, and you can see just about every week we go out and do a profile, and if I zoom in on any one of these profiles, you can see there is a little bit of structure to it. The data goes down to a certain extent. Now we've got some time interpolation gaps in here. That's just because of AQUARIUS trying to fill in those timestamps for us. But this isn't particularly a useful way to visualize our data. We can look at the depth information the same way. I believe this is my depth time series right there. If I right click and quick view that data, it's going to show us that once again every week we go out there and we do a depth profile. There are a few weeks when we weren't able to get out there. These 2 weeks here, one in August and one in November. But again, each one of these depths represents a specific time when we went out there and did a survey, and you can see the depth went from very shallow up to very deep. And again, we've got a few interpolations here where AQUARIUS has said there should be an extra time tag in the middle. So what we actually want to do is visualize this sort of three-dimensional data where we've got time, depth, and a value in a specific way. And we've got a specific toolbox for doing that, the profiling toolbox. So if I drag that out onto the whiteboard, you'll notice here that there are two input ports. The top one is the depth input port. So I'm going to wire this one up to the depth time series. There we go. And now the other one is for the input value, or the parameter that we're interested in looking at. And in this case, I'm just going to look at temperature. It's a pretty solid parameter, so we'll just wire that one in. If I double click on the profiling toolbox, it's going to initialize for me. That'll take just a few seconds. And it's going to do some calculations for us. The first thing you'll notice, if we go into the raw data tab right here, and we'll just expand that one a little bit, is we can see our data here with the depth and value and date and time those measurements were taken. But this sort of vertical format of data isn't exactly the way we want to chart data or visualize data. We're going to have to do an interpolation, or what's called a gridding of the data. So we have a few controls for doing that. In the profile info and gridding, we can select the number of essentially depth slices that we want to have a look at. Now in this case our data goes from about 0 meters down to 14 meters, so 14 depth bins, or essentially 1 meter in between each of the depth slices, would be good. And then the number of time bins, essentially how many vertical columns do we want to interpolate across. In this case 100 is probably good. We actually have 47 profiles. We're dealing with a year of profiling data gone out about weekly, so maybe we could reduce that number to 50. And then we can grid that data. And what that's going to do is it's actually going to interpolate any of the missing data we had. Remember, we had those 2 weeks, one in August and one in November, when we had missing data. It's going to do a smooth interpolation across those. And if we look at our gridded data pane here, you can see all of our data now in a matrix format with the depths going across the top and the timestamps that are now constant. So we've interpolated all of these values at a specific depth. And of course, we could export this matrix of data if we wanted to have a look at it. But we can instantly visualize it in the chart that we have right here. If I just minimize that off to the side, we can visualize things right here. And we've got a Profiling Plots Manager tab right here, which controls how things are plotted. We can change the number of decimal places that we're looking at, so very fine changes will actually show up in the plot. And there are various ways of plotting things. We could do things as a color contour plot, that is what we've got right here. We could do it as a color line plot. In this case, 60 different contour lines is probably too many. We could reduce that to, say, 20, which would give us a little more readable chart. I'm actually going to stick that back up to 60 and change back to the color contour plot. That's a pretty useful plot to look at. If we want to look at things in 3D, we could go to a contoured surface, which would be a map of the surface. And as we rotate here, we can see the various ways that the data can be visualized from different angles. And if I let go again, we can see the depth versus the parameter versus the time plotted up right here. We can do this as a wireframe, and you can see it here in a slightly different format, just as a wireframe plot. But one of the most useful ways I find of looking at the data is with the 2D color contour plot. It really allows us to visualize things with the depth going down the vertical axis, the time along the bottom, and we can see the color represents the parameter. So one of the things about the human eye and color is we don't perceive color to be linear. So we can choose a different color map. In this case, I've got the jet color map selected, and that allows us to really tease out events that lie in the top part of our particular sort of parameter range. So you can see here this large influx of warm water, and this is during the summer. So this is a lake that gets fairly warm during the summer, and you can see how far down that warm water extends, almost to about 6 meters in depth. And really towards the end of the summer, the water column starts to homogenize, and we get reasonably warm water all the way through. But as I change my color map, say I change it to the hot color map, one of the things you're going to notice is that this region of hot water during the summer months in the top half of the lake, it sort of saturates out. We don't see the structure in the profiling data anymore here. But your eye does now notice various other things within the data set. You can see this very dark patch right here that's fairly vertical in early March, late February. And one of the things we can then interpret from this particular color map is that there's a large influx. In this case, this Cowichan Lake has a fairly large influx of snowmelt water that will come in during that exact period, the late February, early March. As the snow melts, the cold water is coming in, and we can see that's represented by this very dark color down at the bottom, around 5 degrees Celsius water coming in, going all the way through the water column. And then later on in the summer, we're going to get that significant amount of warming at the top, and then later again in the summer towards October, November, anti-stratification, homogenization of the water column towards November and December. So it really allows us to tease out certain elements of our data set. So one of the things we may want to do here is actually look at data on specific profiles. So what we can do is we can switch on the profile chart, which is a two-dimensional sort of cross-section. And what we can do is switch on a depth profile 2D plot at a specific time. And we'll switch on the cursor. Now it's changed my plotting options here. I'm just going to go back to color contour plot. And you can see here my red vertical line. If I change my color map to jet, that'll show up a little better. That's the time that I'm looking at that specific profile. And we'll also get a grid of the data showing the depths and the exact values of the temperature. So I can tick that back and forth, and we can look at different periods of time when we have specific profiles. And of course, any one of these can be exported as a CSV. This grid is very easy to export. So one of the other things you may want to go and have a look at would be a time series at a specific depth. So if I switch on my time series at a specific depth plot, and then if I go and switch on my marker to show a time series at a specific depth, and once again I'll go back to my 2D color contour plot here, we can see that visual red line at a specific depth that'll show us essentially a time series at any one of those specific depths. And if I go back down here, I can tack my time series marker, my cursor, up and down within the profiles, and you can see here down at the bottom how that profile, that time series, changes depending on what depth I'm looking at. And of course, since this is a time series, we could actually export this, and we could create an output port, which would be, let's see here, the depth or the temperature time series at 3.4 meters. And if I click Create a Port, it'll actually create a port for me at 3.37 meters. There's a time series of data now. And if I, of course, close this toolbox, I now have a time series sticking out here, which is the Cowichan.csv temperature at a depth of 3.37 meters. I could quick view that data. It'll actually show me just there what I have over the course of the summer months or throughout the entire year at 3.37 meters. That's what my water temperature profile looks like. So that's one way of doing things. This is a fairly old methodology. We don't have any automation in it in terms of doing the profiling. So one of the things we've done is automated this process for some of the automatic samplers out there. I know YSI has a specific piece of hardware, a sounding buoy, that will actually lower a sensor automatically every hour. And what we've got in the profiling toolbox under the File menu is an option to import the .dat file that comes off those YSI profilers. So I have an example here, and it's the Shawnigan Lake Auto Profiler .dat. If I double click to open this one up, there are many parameters on the multi-parameter YSI sonde that's being lowered. So we need to pick, of course, the parameter that we want to have a look at. And again, I'm going to pick temperature in this particular case. Since we'd be dealing with a four-dimensional plot, if we chose to plot multiple parameters on top of each other, we'd have to do that in tabs. But I'm just going to look at temperature for this case. So if I double-click on temperature, it's going to bring the data in, and again, it's going to grid the data for me. So there's a fair amount of calculation that's necessary here. And what we get are the data plotted up for us with the original gridding options from our last profiling. So if I go back into my profile info and gridding, go down to the bottom, we can see here again we've done 50 time bins. In this case, we actually have rather a lot of soundings. In this case, the automated sounder has done nearly 700 depth soundings for us. So we could actually look at a lot more information in terms of the soundings. We could probably crank that up to around 200. If I regrid my data, we're going to see the plot change, become a little more vertically stratified. So you can see here a lot more fine structure in terms of what we're doing. Again, a range of 1 to 14 meters is probably appropriate for the grid of the data here. And again, we can see right here my cursors are showing the time series at a specific depth and also that vertical profile at that specific time. These charts are, of course, exportable. We can right-click on the charting area right there and click to export them. We just get the export dialog, and here we can export them in various formats. We can export them to the clipboard. If we want to drop them directly into a report, we could export them to a file, in which case we need to give it a file name, and then we need to define the dimensions of the export that we'd like to do. So of course the chart itself can be exported. And that concludes how we're going to use the profiling toolbox to visualize two-dimensional data in AQUARIUS.